My name is Stuart. I'm the CEO and co-founder of Scaled Robotics. We are a Barcelona-based startup that is automating progress monitoring and quality control for construction. I think the best place to start, to be honest, is just with a quick story. And our story starts, in this case, in Oslo, in the middle of winter. Horrible, minus 10 temperature, a very difficult place to construct anything. And this is a 30,000 square meter development right down by the waterfront. And they were trying to build structural steel and concrete to plus or minus 10 millimeters, which personally I think it's kind of normal within the industry, but I think it's very ambitious when you're kind of under this kind of pressure with the environment. But unfortunately, on this particular project, a steel beam was brought to the attention of site management, and it was 4 centimeters away from where it should have been in reality. And if this had been left undiscovered, it would have cost thousands of euros in extra costs. It would have cost the valuable time of at least 8 site managers running around like headless chickens, trying to work out why things weren't fitting, why materials were piling up, and why the project was not progressing on this particular rooftop. And it would have cost at least 1 week of schedule delays on that particular area of the project. And I think the crazy thing is that this is considered normal in construction. This is essentially the cost of doing business, that all of us within the industry kind of accept that these kinds of things pop up and you deal with them ad hoc as they come and put your project at risk. But the really crazy thing about this particular issue is that this was automatically flagged up by our AI-powered software platform so that this issue could get fixed at no extra cost while the subcontractor was still on site and critically had not yet been paid for the work. So essentially, better information to make better decisions to be able to de-risk the project. But why did this even happen in the first place? Let's take a couple of steps back and ask ourselves, why did this happen? And we believe one of the problems within construction, not all, but definitely one of the larger problems, is that whilst we're designing digitally, we're still constructing manually. So we put a huge amount of time and energy into building the detailed 3D models of our environment, these incredibly detailed BIM files that we use to be able to construct our buildings. But ultimately, there is a person in the field with a tape measure and a bit of string, pretty much putting things wherever they feel like that day. And I do not believe that people come to work wanting to do a bad job, but construction is complex. We're talking about hundreds of thousands of elements that are being coordinated in time and space to be built in minus 10 in the middle of Oslo. It is very difficult to match up what you intended to build, which is the BIM, with reality. And if we accept that that's the reality of how things are working in the industry, it's insane that there's no quick and easy way of comparing what you intended to build to what has actually been built in reality. So this is essentially what we're doing. We are capturing data on the construction site, and you should be seeing a video of a point cloud. This is the raw data that we're capturing on the construction site. I'm sure a lot of you have probably already seen this before, but you can see the clutter and the chaos and the noise. And this is what makes construction so complex and difficult to work with. So we take all of that data, we upload it into the cloud, and we use computer vision and machine learning to start making sense of reality. And this is something that you wouldn't see as a client, but this is to visualize for you kind of what's going on behind the scenes. So basically, we're taking everything that is not the building that just turned red, and we're putting that to one side because that is not the building. So we're cleaning up and making sense of this complex piece of reality so that we can start to process it and pull out meaningful insight from the project to be able to actually deliver a business outcome. So the first thing we're doing, we clean the point cloud, we align it with the digital model, which is the BIM file, and we analyze every single element within the digital model. And we take something incredibly complex and we try and make it as simple and as intuitive to understand as possible. So the first thing we do is we color code everything, which means that everything gray is no data. That means that we don't have enough information to make an assessment. Probably means that we didn't see it, or we didn't see enough of it to tell you something reliable. Then everything green is within tolerance and has been built correctly. This is good. You should be happy with this. Everything red is missing. In this case, This is a structural wall on the 4th story of a 6-story building. This is obviously information that you would like to have sooner rather than later. And then everything orange is out of tolerance and has not been built correctly. So it's outside of the tolerances that our clients have delivered to us. And the problem is that what you get on the average project is this: everything is orange and everything is out of tolerance. And this is both overwhelming, useless, and quite likely to give a site manager a bit of a heart attack. This is not answering the question: what is putting my site at risk today, and where do I need to allocate resources to mitigate that risk, like the beam that we saw earlier? So what we do is we make all that information searchable. So I can come in and I can search, and I can see that actually this wall is more deviated and more at risk than all the other elements. It's actually 10 centimeters too close to the central core, which means that the pipes aren't going to fit in the later stage in the project, which is basically going to mean that I'm either going to have to redesign a whole bunch of MEP, which is the services, or I'm going to have to rip down that wall and replace it, which is going to cost delays, schedule problems, issues with my subcontractor, kind of all of these 3rd, 4th order events that are going to kind of sneak into my program. So I've immediately, just by catching this early, the immediate direct cost is around 10,000 euros, but we know that that's going to be stretching higher and higher and higher as you go through the 3rd, 4th order events that are going to be caused rippling out from this one particular issue. So what does this look like on a real project in our product? Let's see. Yep. So this is just a screenshot from a little while ago. It's actually a little bit old, but essentially all of that data is now being hosted in a web viewer. So you have access to the same high quality information, whether you're sitting at home or you're sitting in the site. And I know on this project we have some issues with the concrete, so I've immediately filtered out from the 2,500 elements we started with, just these provisions for voids, the areas where the concrete needs to have a hole for the services to run through. And I've said, show me all the missing elements within that category. And that's now 6 elements. I've double clicked on one. I've brought up the image because every single element is automatically tagged with every 360 image it appears in. You don't have to go searching for that information. And then I can actually highlight the element within the image using the highlight element tool so I can see where it's supposed to be. And in 2 seconds, I can very quickly see that there is very much no hole in that concrete. And therefore, this is putting my project at risk, and I need to be able to mitigate that risk. So I've gone from having almost no information about my project to having fine-grained control over everything that is putting my project at risk in that moment. A couple of other examples of how we're doing that. We can also filter by, so we go into element type, we can also filter by specific elements that we're interested in, but we can also filter by magnitude of deviation. So I can say, only show me elements above 25 millimeters of deviation. The ones below, maybe I don't care so much, but above 25, I really do care. That's immediately narrowed down from all of the elements on my site I would need to check to the ones that are really putting my project at risk. Double click on the one on the top because everything's automatically ranked by the magnitude of deviation. It's telling me 419 millimeters out of place. Visualize that with a heat map so that I can visualize all the measurements on that wall. I can see there's a big red lump of missing material. I bring up the image verifies what the software is telling me. There's definitely a big square lump of missing material in the middle of that wall. That is not good. I move on to the next one, having a look at a pipe in the ceiling. It's telling me it's about 9 centimeters out of place. The key thing is here, we're communicating in the language that construction is using today. We're taking state-of-the-art tools to be able to diagnose what's going on, but at the end, the way that we actually deliver that information to people on site is using 2D sections. 2D sections have been used for thousands of years, hundreds of years, but we're delivering them in combination with this incredibly insightful information. So I can come in and I can immediately say, yes, this duct has actually been moved up by 9.5 centimeters, and I can verify that. So better information to make better decisions to keep your project running smoothly. In conclusion, it's been a pleasure to present what we're doing. If you have a project that you think that this could have an impact on, feel free to reach out. We would love to hear from you. We're working in the Netherlands at the moment with Dura Vermeer, doing some really awesome projects. I have to admit, I have a soft spot for the Netherlands. I've really enjoyed working there in the past, and I'm loving the projects that we're doing there now. So yeah, if you're interested, please give me an email.
Well, thank you very much, Stuart. One question that I maybe have for you. What are the tangible world outcomes you have seen at your clients achieve with these technologies?
So I think there are a combination of different outcomes that our clients are seeing from this. So for example, 2 weeks ago on a project that I definitely cannot name, we uncovered a structural issue with some of the beams, which had completely bypassed all the traditional QA methods that they had within the project. And if that had gone through the project, that would have been bare minimum, at least 100,000 euros worth of damages. Not to mention the problem that that project could potentially have been structurally unsafe, and therefore you can imagine the kinds of ramifications that would have for the reputation, but also just for the safety of the building. So catching that issue within days of it actually being installed had a huge impact on that project and on the company. Then there are other things. We process data significantly faster than traditional methods. So something that we are doing on a pilot right now to test this out, we can process data in 3 days turnaround. We're talking about hundreds of thousands of elements in 3 days, what would traditionally take 3 months. So you're getting this valuable information that would have taken you 3 months to get, you're getting in 3 days. So it means that you can completely change the feedback loop that your project has to be able to test those assumptions, de-risk the project and move forward. So we're seeing some pretty interesting stuff popping out over the last couple of months.
Wow, amazing. But then construction is really conservative. So what would you say to those that are happy with the process today? Why add one more bit of software to the whole list that we're trying to use right now in construction? What would you say to those people?
That's a tough conversation. We have this conversation more often than not. But I think it's really not about software and it's not about technology. You have to ask yourself, how much are you spending on clashes in the field? How much are you spending every week, every month? It's probably going to be quite a lot. How much of your budget do you allocate towards risk and uncertainty? How much risk are you baking into your project at the end, where you're going to erase potentially the margins that you have because you don't have a good enough control over what is actually being constructed? Look back over your previous project and look at how much litigation costs you have on average. Now imagine you could just ignore the technology. Imagine that there was a process or a person that you could employ that would be able to mitigate those risks. Someone that maybe had the experience of 1,000 projects to be able to bring to bear, to be able to flag those issues. Would you not hire that person? Of course you would hire that person. But as soon as we start talking about technology or about software, it changes the dynamic. So don't look at it in terms of technology. Look at it in terms of risk on your project that you can mitigate and almost remove.
Yeah, that's smart. Yeah, that's really smart. Well, in which countries are you now active?
We're working in the UAE on some crazy projects, in the Nordics, the UK, the US, the Netherlands, of course, Luxembourg. We're going to be starting a project in Switzerland very soon. So we're we're all over the place these days.
Cool. That sounds very good. Well, it was great having you with us, and wish you some good business in the next coming months, of course. Hope to see you soon.
Hope to see you soon as well.
Bye-bye, Stuart.
Bye.